Yay!
Yay! Here's another problem with electric forces that I've seen in just about every textbook. And the example is that I've got a couple of positive charges hanging from the ceiling, and they're repelling each other. And when they repel each other, they make, on these strings, they make an angle, theta, with respect to the vertical. And so if I know, like, the masses of these things and I know the angle, I can compute the charge. I can compute the charge on each one. So let's try to find that. What is the charge given the angle and everything else? Okay, so now we can apply our, it looks like this is kind of like a statics problem. So these things aren't accelerating, they're just hanging there. So let's apply our Newton's laws. What force, let's look at the one on the left. What forces are acting on the thing on the left? I have tension going up this way, and then I got mg going down. And then what other force is acting? I've got this, I've got the electric force acting because they're repelling each other. Okay, so that's on the left there is sort of my free body diagram. So let's just apply Newton's laws. Okay, so in the x direction, what have I got? I've got T. Okay, I want the x component of the tension. So that looks like T sine theta because it's opposite to the angle. The x component is opposite to the angle. So it's going to be T sine theta is going to the right. And what's going to the left? Going to the left is the electric force. All right, so what is the electric force? The electric force is K times Q1, Q2. Well, they're both the same Q, so let's just say Q squared over the distance squared. That's the magnitude of the force between them. And then I know it's to the left, so I know I'm going to have a minus. And so this is going to be K Q squared over, okay, what's the distance between them? Well, it's this distance. What do I know? I know what L is. So, okay, half of that distance over here to the origin, that's L sine theta. So it looks like this had better be 2L sine theta. And then I better square it. All right. So that's it, right? mg is pointing down. So that's it for the forces in the x direction, and they equal 0. They've got to balance. In the y direction, what do I have? I have the other part of t cosine theta minus mg equals 0. Okay, so t, this will get me t, won't it? This is mg over cosine theta. And so it looks like I can just take this, I can plug it right in there, so I can get rid of t. And remember, the idea is I'm trying to solve for q here at the end. So, okay, so let's just, let's plug this stuff in and see what we get. I got mg sine theta over cosine theta, so this looks like mg tangent theta is going to equal, let me bring the kq squared business to the right-hand side. This is going to be kq squared over 4L squared sine squared theta. All right. Well, there's not a lot of simplifying to do, is there? So I'll just solve for q. We get kind of a long expression. So the charge on these things is just going to be square root of a big mess. It's going to be 4L squared sine squared theta times mg tangent theta divided by k. Okay, I mean that's going to be the final answer. You can, I guess you can simplify it a little bit. So if you want, you could take some of that stuff out. You could just go backwards and make this 2L sine theta, if you like, by mg tangent theta over k. You could write it like that. That's fine. Yeah, this is, I mean, there you go. Let's put some numbers in just to see what kind of thing we would get. Let's suppose, I think what I used is 10 degrees for theta. I think I used the mass as 1 gram. So these just are little tiny charges. And L 30 centimeters, 0.3 meters. I think that's what I use. So that's all we need to know, right? The length of the string, the angle, and then the mass. And if you put all this stuff in, what you're going to wind up getting is something that doesn't sound too crazy. That each of these little masses has a charge of 46 nanocoulombs. All right. So this is how to solve this, this fairly typical problem. This is also kind of a neat way to, if you can get this set up where these things stay in a plane, maybe they're on sheets of aluminum foil or something. But this is how you can determine what the charge is. This is a useful way to measure the charge on suspended charges like this. Because all you need to do is measure the angle, which is pretty easy, and you can actually measure the charge, which turns out to be a lot harder.